Today, children, in this session, we are going to see probability. So, now I am going to introduce probability. What is probability? Probability means probably. In English, we'll use the word probably. Probably means, for example, if you take rain, it may rain, it may not rain. So, while going to school or anywhere, you will think the cloud, it is cloudy. So, shall we take the umbrella or not? So, it is uncertain. We cannot predict. Surely today it will rain, so we have to take umbrella. So that uncertain event only we are going to find out in the probability. So you will get confused. For example, if you take a coin, when you throw a coin, roll a coin, we don't know there are two sides. One side is head, you all know, other side is tail. Can anyone say surely head will come? Unless otherwise in the coin, both sides head is there, then you can say head only will be the result. Otherwise, it is unpredictable. So, the probability of an event expresses the likelihood of an event occurring. So, any example you take, for example, die. How many sides are there? 6 sides are there. So, when you take the die, each side faces 1, 2, 3, 4, 5, 6. 6 sides. Suppose if I throw a die, if I want the outcome 4, it won't come in the first time. Maybe any other time it will come. So we have to wait. So this uncertain event, we cannot predict. That only we are saying probability. So probability, if you see on the line, it starts from 0 and 1. So the probability is between 0 and 1. Between 0 to off, it is event that then unlikely to occur. From off to 1, as it is likely to occur. In 0, when the probability is 0, we can say it is impossible event. Always probability for impossible event is 0. And if it is sure event or certain event, then probability of sure event is always 1. Then we'll go to some experiment. What is experiment in probability? Experiment means a repeatable procedure with a set of possible outcomes. For example, if you throw a die, you are getting 1, 2, 3, 4, 5, 6. So in the experiment, throwing die or throwing a coin, like that, cards, like anything you do, that procedure is called the experiment or process that generate. We can say process that generate. I have taken only this example. There are many examples. Cards, dice, coin. There are many examples. Even selling goods. We can sell, we cannot sell, like that. Then next, outcome. A possible result of an experiment. When you throw a die, suppose we get 6. That is a result you are getting. That is only called outcome. Even in computer we will say input output. Input means you will process the procedure with the feeding the number in the computer. When you get the result, what you will say? Output in computer. But here in probability we will say it is outcome. The result is called outcome. Now what is sample space? All the possible outcomes in that experiment is called sample space. All possible outcomes of an experiment. For example, if you take one coin, what are the possible outcomes there? Head or tail? It is called sample space. So what is a sample space? How many possible outcomes here? 2. So it is called 2 is our sample space when you throw a coin once. Suppose when you throw coins twice. For example, if you throw a coin twice, what will happen? Throw a coin, your sample space will be 2 coins you are throwing. So it may be 2 times. First time maybe 2 heads. Second time maybe head and tail. Third time maybe tail and head. Fourth time maybe 2 times tail. This is the only possible outcome. So sample space, number of sample space in this is, we can denote it as n of s, which is equal to 1, 2, 3, 4. And then what is a coin? If you throw a coin, first it is 2 times. Suppose you throw a coin 3 times. 2 times you are getting answer 4. Suppose throw a coin 3 times. What are the possible outcomes? H, 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 H for head, T for tail. And maybe first time tail, T, H, 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 T, H, 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 T. Then what you are getting? H, T, T, H, T, H, then H, T, T, H, H, T. So H, 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 first take one tail, 2 heads we are getting. Then here remember how to calculate this. 3 tails, we'll have usually 3 tails, 3 heads. Just to remember, I am telling you. First take first place tail, middle, last with 2 heads. Next is 1 head, 2 tails. So here first place head, then middle place head, corners tail, then last place head, 2 tails, then last place 2 tails. So 1, 2, 3, 4, 5, 6, 7, 8. Cut this. So remember, suppose you are not able to understand how it's coming, remember at least 3 times heads, 3 times tails. Okay, 3 times heads, 3 times tails. First time you are taking head, 2 tails, 1 tail, 2 heads you are getting. Second time middle you are getting first and last head. That is, we are taking 1 tail, 2 heads because 3 coins here. So middle and then last. So 2 heads in front, T is in middle, T is in first, T is in middle, T is in last. Suppose head and 2 tails means head is first, head is middle, head is last, and tails will be what you will get in front. Tails will be here, 1 head, 2 tails. So head will be front, middle, last. Tails will be, suppose we have taken head in front, next 2 will be tail. Center head, first and last will be tail. If you take last place is head, third place is head, first 2 places will be tail. And all the 3 will be tail. So you are getting 8 times. So n of, n means total number of possibilities. Sample spaces here 8. This is for 3 times when you throw a coin. This is 2 times when you throw a coin. 1 time when you throw, already I told, 1 head, 1 tail. So it is only n of s is equal to only 2. So this is only sample space for the coins when you throw 1 time, 2 time, 3 time. So if it is not clear, I'll write again here. When you throw the coin, I'll explain again. First you take H 3 times, H for head, tail for T, T is for tail. First I am taking condition 1 tail, 2 head. So remember, tail in middle, tail in front, tail in middle, tail in last. So you are getting 3 coins only, no? So it will come, only 3 will come. Possibilities. Next is I am taking 1 head, 2 tails. So 1 head in front, 1 head in the middle, 1 head last, third place. Then 3 tails. So this is the way you have to write. You have to get 8 times 3, 1, 2, 3, 4, 5, 6, 7, 8. By using this only, we are going to do the problems. Okay. Now we go back to the definition. Sample space now we finished. Okay. Now in general, what is the formula? Probability of the event formula. Probability of the event A or B or C, whatever it is. What's the formula? Number of ways it can happen by total number of outcomes. This is it. Otherwise, number of favorable outcome by number of possible outcome. Usually we'll say, in if you take variables A or B or C for event, suppose you want to get any event of getting 4 in a die, I'll take it as A. 4 how many times it will come? In a die, 6 outcomes are there. One die, remember, I am not throwing 2 dice, only one die. How many outcomes? 6. But I want the possible outcome. What I want is actually probability of getting an 4. So that means 4 will come only one time, divided by, you know how many outcomes in die. For one time if you throw a die, 1, 2, 3, 4, 5, 6. So your sample space is 6. So you are getting 1 by 6. That is probability of A is equal to, what is the formula? N of A by N of S. This is your formula. Suppose you take any variable can be taken. If you take B means N of B by N of S. We know A is an event of getting favorable outcomes, and that is probability of getting an outcome. Here N is a N of A means number of favorable outcomes by total number of outcomes. For example, in probability we can say success and failure. What is success means, if you are expecting your probability of outcome is 4. Suppose if you get 4, that is a success. If you are not getting 4, that is a failure. So in probability we usually denote success means probability of A. Failure means probability of A bar or probability of A dash. Any way you can do it. What is a formula in probability? P of A plus P of A bar is equal to 1. So failure means what you have to do? 1 minus, bring this P of A this side. 1 minus P of A. So P of A bar, failure is 1 minus P of A. So you have to write P of A is equal to 1 minus P of A bar is equal to 1 minus P of A. If they ask you find probability of getting 4 means, you can usually N of A by N of S. Otherwise, P of A bar means not getting 4 means 1 minus N of A by N of S or 1 minus P of A. This is a rule for finding success or failure. Now I am taking one example I am doing. Express the sample space for rolling a 2 dice using a tree diagram. Just for example, rolling 2 dice. Okay, suppose you take 2 dice here. 2 dice is taken. So what is a sample space? I am going to show you. 1, 2, 3, 4, 5, 6. So first one die means you'll have 1, 2, 3, 4, 5, 6. This is your sample space 6. This total number of outcomes will be 6. So your sample space is 6. Suppose you have taken 2 dice taken. So you must take a tree diagram for 1, 2, 3, 4, 5, 6. For 2 also same way. 1, 2, 3, 4, 5, 6. Again for 3, 6 lines you have to draw. 6, 1, 2, 3, 4, 5, 6. Again for 4, 1, 2, 3, 4, 5, 6. This is tree diagram. You have to draw neatly. 1, 2, 3, 4, 5, 6. Again for 6. 1, 2, 3, 4, 5, 6. So remember, one die means you are getting only output is 6, so your sample space is 6. But here our sum is finding the sample space if we roll 2 dice. So for each one you will get 6 result. So each one is connected with 6. So now you can write sample space equal to, if you take this 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. You can write it as 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. If you take 2, same way 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. So 2, 1, 2, 2, etc. 2, 6. If you take 3 means 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. So 3, 1, 2, 3, 6. Same way 4, 1, 2, 4, 6. And then 5, 1, 2. It goes till 5, 6. 6, 1, 2, 6, 6. So if you total all this, 6 outputs here if it is 1 die. 2 dice means 6 power 2. 6 into 6 is equal to 36. So a sample space, total number of outcomes if you throw 2 dice, n of s is 36. Suppose if you do 3 dice, you have to take it as 6 cube. So 6 into 6 into 6, 36 into 6, 216. So your total outcomes here 216. Children, I hope you understand tree diagram and finding sample space. This is actually your answer is 2 only. So this is your answer. Just I showed how to do for 3. Same way you will get again each element. How you will do tree diagram for 3? Again each element will have 6 side here. Each one. So you will get 216 elements. I hope you understand, children. Now our second example is a bag contains 5 blue balls and 4 green balls. A ball is drawn at random from the bag. Find the probability that the ball is drawn. First part, you have to find blue or not blue. You know, in already I explained, blue means here it is a success. When it is not, means it is a failure. So now first we'll find out blue ball. If I take A variable is getting probability of getting blue, then A bar will be not getting failure, it is not getting blue. You know the formula I already explained, P of A is equal to N of A by N of S. So you have to find out first N of S. What is N of S? How many total only N of S? How many balls are here? 5 blue balls, 4 green balls. So 5 plus 4, 9. So N of S is equal to 9. How many blue balls? Remember, 5 blue balls, 4 green balls. But what is our question? First one, find blue. I have taken blue as A. So getting probability A, I mean blue color is, here it is given 5 is 5 blue balls. So it is 5. So therefore probability of getting blue ball is N of A by N of S. You know N of A is 5. Total is 9. So your answer is 5 by 9. Now we are going to find out failure. What is that? P of A bar. Not blue. You know the formula P of A bar is 1 minus P of A. That is 1 minus, what is P of A? We found 5 by 9. So 1 minus 5 by 9. Cross multiply. 9 into 1, 9. I have taken LCM as 9. 9 minus 5 by 9 equal to 4 by 9. So a failure, not blue. Second part answer is 4 by 9. Blue is 5 by 9. Children, I hope you understand this sum. Please go through. If you don't understand, go through 2-3 times.